to this tutorial on naming alcohols. I have 3 compounds for practice in this screencast, so let's get started. First off, I have the following compound. Okay, of course, the first thing we want to do with any compound is identify the highest priority group, and then make sure to include that group in the longest continuous parent chain. The highest priority group I have here is the alcohol, OH hydroxyl. So I want to be sure to include that in the parent name and give that the lowest possible carbon number. Lowest possible carbon number it can get is 1 because my longest continuous chain, highlighted in yellow here, can actually go up this 3-carbon chain, and then at the split, it does not matter which way I go, left or right. I still get the same number of carbons. So here's my carbon labeling. So with this 5-carbon, its parent name is pentane. Since I have an alcohol, that changes the name to penta. I drop the E and add OL to let me know that I'm dealing with an alcohol. And since it's on carbon 1, there is no need to place a number in front. Now that we have the parent chain, we identify any substituents that are around. Here we've got one single substituent, and that is this ethyl chain hanging off of carbon 3. So in naming the compound, we go ahead and put the substituent name in front of the parent. So the name of this compound will start with 3-ethyl. And now I continue on into the parent name. Again, no need for the 1 in front. And say pentanol. So the name of this compound is 3-ethyl pentanol. Okay, let's go ahead and take a look at another structure. This compound will be a little bit different. As always, the first thing we do is identify the highest priority group. And the highest priority group on this cyclohexane ring is, well, we've got a bromine, a OH, and a methyl CH3. So the bromine and methyl both are the same priority, and the hydroxyl OH is the highest priority group, being an alcohol. So this will be named as an alcohol. Parent chain that's longest continuous is that cyclohexane ring. So for naming, what ordinarily would be cyclohexane, E is going to get dropped, and we're going to name the parent as cyclohexanol. So much like our last compound, the OH is at the end of a chain, or in this case on a ring. There is no need to designate the location of it, since by default, being the highest priority group, it is carbon 1. Now we just need to number in a direction that gives the other substituents the next lowest possible carbon number. We're going to number our hydroxyl carbon 1, and then to give our next lowest combination for bromine and methyl, we're going to go counterclockwise. So bromine gets carbon 2, and the methyl group gets carbon 5. Preference in naming to bromine, since it's first alphabetically. So in putting the substituents before the parent, we list bromine first. So 2-bromo dash 5-methyl, and then we attach the parent name cyclohexanol. Okay, here's the last compound we'll take a look at for this session. So, first thing we always do, identify the highest priority group in this molecule. This is a alcohol, not an alkane because of the 2 hydroxy OHs. So we're not dealing with just a single alcohol, we're dealing with 2 alcohols. We want to make sure to include both hydroxyl OHs as part of the parent chain to number it along this 6 carbon length, highlighted in yellow. Substituent off the highlighted in yellow is not part of the parent chain. That would not be the parent because it does not include the highest priority group, which is both hydroxy OHs. We're going to number from left to right in this case. That'll give us the lowest possible carbon number combo for the 2 OHs, 2 and 4 rather than 3 and 5. A 6 carbon chain is hexane. Since we're dealing with 2 hydroxy OHs, it's not just called hexanol. We have to designate that we have 2. So we actually keep hexane in its entirety and just add diol, prefix di for 2. And then in front we want to number so that we can tell people the location where those 2 hydroxyls are. So 2, 4 dash hexane diol. This would just be the parent name. The one and only substituent we have is this 1, 2, 3, 4 carbon butyl. So let's go ahead and number its location on carbon 3, 2, 4 hexane diol. So the full name of this compound is 3-butyl 2,4 hexane diol. Main thing to take from here is about the hydroxyl OHs both being on the parent chain.